Today, we are going to introduce some lab equipments which is used commonly in laboratory. Now, let's take a look into hot air oven. Hot air oven is a laboratory instrument that uses dry heat to sterilize laboratory equipment and other materials. We can sterilize glassware like flasks, pipettes and test tubes, powders like starch, zinc oxide and sulfadiazine, materials that contain oils, metal equipments like scalpels, scissors and blades by using hot air oven. The widely used temperature-time relationship in hot air ovens to destroy microorganisms are 170 degrees Celsius for 30 minutes, 160 degrees Celsius for 60 minutes and 150 degrees Celsius for 150 minutes. Now let's discuss about the parts of hot air oven. This is the external cabinet. The external cabinet is made of stainless sheets. It covers the inner chamber. This is the temperature control knob. It maintains the accurate temperature during the entire cycle. It also controls the temperature. This is the heating switch. It controls the heat. This is the power switch. It helps to turn on or turn off the hot air oven. This is the timer to set the time. This is the inner chamber. The inner chamber of hot air oven is made of stainless steel. This is tray slots. The inner wall of the chamber contains several tray slots that hold the trays. Working principle of hot air oven is sterilization by dry heat and is performed by conduction. The temperature is consumed by the surface of the objects, then moves towards the core of the object, coating by coating. The whole object will ultimately attain the temperature needed for the sterilization to take place.
The centrifuge. A centrifuge is a device that uses centrifugal force to separate various components of a fluid. The rotating unit, called the rotor, has fixed holes drilled at an angle visible inside the smooth silver rim. This is the centrifuging tube. The sample is placed inside this tube and it is placed in the slots. Another centrifuge tube filled with water is placed in the slot in order to balance the centrifugal force. The two centrifuging tubes are placed in opposite direction and centrifuged. Radial acceleration causes denser particles to settle to the bottom of the tube, while low-density substances rise to the top. A centrifuge is a device which is used to separate fluids of different densities or liquids from solids.
This is weighing balance. A weighing scale is a device for measuring weight. Balances measure the mass of an object and are used in science. In many industrial and commercial applications, scales and balances to determine the weight and or mass of the things. Now, we can measure the weight of given sample. Before measuring the weight, we first press the tire button. Then we place the sample in the balance. Here we can see the weight of the sample. The main advantages of electronic balance is it is easy to use and minimum efforts are needed, easily portable and small in size.
Digital colorimeter. It commonly used to determine the concentration of a known solute in a given solution by the application of Beard-Lambert law. In this technique, the concentration of compound is determined by measuring the intensity of color. The principle of colorimeter is Beard-Lambert law. The law states that when a monochromatic light passes through a solution, the absorbance is directly proportional to the concentration of the solution and the path length of the light. Let's see the instrument. Filter. It absorbs most of the light and it permits only the light of the corresponding color. We can change the filter depending on our requirement. Cuvette. It is a glass material. Make sure there is no any contaminations, no scratches. Hold at the top. If hold at the bottom, fingerprint impressed, it will affect the transmittance of the light. This is the cuvette holder. Blank. Blank is the reagent used for the reaction. It do not have the analyte which is going to be measured. Clean the cuvette very well. Place at cuvette holder. Before starting the experiment, we have to set the optical density at 0. Then we can take the optical density of various solutions. Thus, we can determine the concentration of compound by measuring the intensity of color.
Rotary Shaker. A shaker is a laboratory equipment used to mix, blend or agitate substances in a tube or flask by shaking them. It is mainly used in the field of chemistry and biology. A shaker contains an oscillating board that is used to place the flasks, beakers or test tubes. Although the magnetic stirrer has lately come to replace the shaker, it is still the preferred choice of equipment when dealing with large volume of substances. Let's see how this rotary shaker works. This is power button. This is speed adjuster. We can adjust speed. And this is timer for setting time. An orbital shaker works by generating a circular shaking motion at a slow speed of 25 to 500 rpm. Rotary flask shaker works on the principle of motorized shaking, which works on brushless DC motor with a variable speed function.
Magnetic stirrer. A magnetic stirrer is a device widely used in laboratories and consisting of a rotating magnet or a stationary electromagnet that creates a rotating magnetic field. This device is used to make a stir bar immerse in a liquid quickly spin or stirring or mixing a solution. A stir bar consists of a magnetic bar used to agitate a liquid mixture or solution. Stirring bars are coated with Teflon or glass so they are chemically inert and do not contaminate or react with system in which they are immersed. Now we can discuss about the parts. Probe. When the external temperature sensor is plugged in, probe icon is lit. LED display. LED displays the real working state and all settings. Temperature control knob. Set the temperature parameters. Speed control knob. Set the rotatory speed. Let's see how it works. The sample is taken in a beaker and the stir bar is immersed in the solution. The bottle is placed on the working table. Choose to heat. Turn on the heating power switch. The heating indicator will light. This means the heater is working now. Adjust the speed control knob. Rose to record speed.
This is digital ultrasonic cleaner. It utilizes ultrasound waves in order to clean certain items including jewelry, scientific samples, lenses and other optical parts. There are varying levels of ultrasound used depending on the item that need to be cleaned, but it mainly falls between 20 kHz and 400 kHz. Ultrasonic cleaners can be used on a large scale for factory equipment and large machinery, but home versions are also available. The process is able to remove contaminants like grease, oil, dirt without actually damaging the item itself. In this, the object to be cleaned is placed in a chamber containing a suitable solution. It can be aqueous or organic solvent depending on the application. The cleaning normally lasts between 3 and 6 minutes but can also exceed 20 minutes depending on which the object has to be cleaned, which hold the dirt on instrument surfaces. This facilitates the cleaning. Let's see how it works. As the sound waves move through the liquid cleaning solution, they cause the formation and bursting of millions of small bubbles. This cavitation process functions by disrupting chemical bonds. A high frequency wave is used that agitate the liquid within the sink, creating a rapid formation and collapse of bubbles, also known as cavitation. As bubbles collapse during the cavitation process, the cleaning solution rushes into hard to reach the areas of object submerged in the sink. This process is highly effective to gently removing all contaminants and dirt from both the surface and hard to reach areas of intricately shaped objects. The resulting cleaning of contaminated instrument is more efficient as compared to hand scrubbing with a scrub brush.